Hey everyone, just here with another short video on using CalcPlot3D. So this one is going to focus on 9.6, which is parametric functions. So we've already seen a little bit of these with doing lines, and so you're going to use that same command here. You're going to add a space curve. Now, we use Desmos for the 2D things, but if you do want a space curve that's in 3 dimensions, then you do want to use CalcPlot3D here. I'm just going to look at the preset. So we get this spiral shape, and that's coming from the cosine and the sine that gives us the unit circle. And you can actually do the 2D stuff that you did in Desmos here by clicking Restrict View to 2D. And so you literally see this unit circle. So I'm actually going to change my bounds to 0 to 6 pi. So it does kind of 3 rotations of my unit circle. And if you want to check, you can actually animate this. So again, this is completely ignoring my z coordinate. And goes around. There's 2 pi. Second rotation, there's 4 pi. And then the last one, there's 6 pi. And then it stops. Okay, and so I'm going to unrestrict and start over. So again, this z, right, has time there. And so as time goes up, our height goes up. And we can see that happening as we go around. So again, there's 1 rotation. There's 2. And then our last one ends at 6 pi here. Now you might be wondering, what the heck are all these like extra doodads, all these extra vectors going on here? So the blue one is the position vector, which I'll talk about in a second. The black and the green are the velocity and acceleration vectors. So we're going to actually talk about these a lot more in 9.7 when we introduce derivatives for parametric functions, because just like in Calc 1, the first and second derivatives give you velocity and acceleration respectively. But if we don't want them, because we haven't talked about them yet, then we can just take them off. We can click this wheel here and remove velocity vector and acceleration, and it leaves just my position vector. And I just want to do that to remind us that the parametric functions themselves give us vectors. So how do we get a curve? It's always the terminal points of our vectors, right? The end points. So if you see where the arrow ends or where the vector ends, that is always the point along our curve. Okay. So the last thing I wanted to highlight was, again, just kind of emphasizing that you need not use Desmos for 2D stuff. You can do everything in CalcPlot3D. So basically just ignore your z coordinate if you wanted to do another one that we did in class, like the spiral in 2D. We can do t times cosine, t times sine. So this has it at different heights, but I can, again, restrict view to 2D. Now this is getting way too big here because I'm multiplying eventually by 6 pi, which is 6 times 3.14, which is pretty big. So I'm going to zoom out a little bit. And you can see the 3 rotations, right? So I start here. Here's 1 circle, second circle, and then third circle. But because I'm multiplying by t, my radius is increasing as I go around. And so that's why we get this spiral in 2D. So again, you can just hang out in CalcPlot3D and do really anything that you could have done in Desmos there. So just wanted to show that off, and that's all I've got. So thank you for watching.